our group project. Firstly, our aim is to conduct a physical experiment to collect the database on the outcome of randomly selecting sweets from a bag. Secondly, we want to compare the difference between experimental probability and theoretical probability. Lastly, we will calculate the percentage difference between the two to see how accurate our experiment is compared to the expected result.
And now, I'm going to talk about significance of project. This project helps us understand how probability works in real-life situation. By completing this assignment, we learn basic statistical concepts through a simple activity of randomly picking a sweet from a bag. The possible outcomes were caramel, grapes, or milk. We also compare theoretical probability with our experimental result and measure the difference between them. The experiment used 30 sweets with replacement, and all data collected was recorded for analysis and future use.
We are from group 3, and for our experiment, we get drawing sweets from a bag. There are 3 flavors of sweets. For the first one, grape. Second one, caramel. And the third one, milk. And then we are gonna put the sweets into the box. We need to shake the box so it will be picked randomly. Then I will pick the sweets from the box randomly with my eyes closed. Every pick will be recorded on a table. Then I will put back the sweets that I have picked up into the box again, and we will mix the box. And then I will repeat the process for 29 more times.
For this experiment, I observed the frequency of 3 sweet flavors, which are caramel, grape, and milk. Each flavor had a total of 10 sweets, making 30 sweets altogether. From the observation, caramel appeared 8 times, grape appeared 16 times, and milk appeared 6 times. This showed that grape was the most current flavor, while milk was the least. Next, we will discuss the probability based on the result of the experiment. The theoretical probability for each flavor is the same because the number of each flavor is equal. So the theoretical probability for caramel, grape, and milk is 10/30. However, the experimental probability is different based on the result obtained. The experimental probability for caramel is 8/30, for grape is 16/30, and for milk is 6/30. So that's all the result we got from our experiment.
And then, for the question number 4, what is the experimental probability the selected sweets are not caramel? In this situation, we can use the formula PA prime equal to 1 minus PA, which is the probability of not caramel equal to 1 minus probability caramel. So that 1 minus 8/3, and the result will be 11/50. And for the question number 5, it's just like same with the question number 4, but is it asking for the theoretical probability of sweet that not caramel? So that probability of not caramel equal to 1 minus probability of caramel, which is 1 minus 10/30, and the result will be 2/3. And for the question number 6, it's about explain why the experimental result may not exactly match theoretical probability. And is it because each time we pick a random sweet, change can cause different outcomes, and the number of picks may be too small to match the expected ratio. This small amount of sweets can make the result of experimental and theoretical probability slightly different.
For question A, we need to integrate 1 over 7 x plus 1 dx with upper limit 4 and lower limit 3. First, we take the constants out of the integral, so it will become 1 over 7 integrate x plus 1 dx, upper limit 4 and lower limit 3. Next, we integrate the expression x plus 1. The integral of x is x squared over 2 and the integral of 1 is x. So together we get x squared over 2 plus x. Now we substitute the upper and lower limits, which are 4 and 3, into the equation. When we evaluate the numbers at x equal to 4, we get 12. At x equal to 3, we get 7.5. Therefore, the answer for part A is 1 over 7 plus minus 7.5 equal to 0.6429. For question B, the integral is split into two parts because the function changed at x equal to 3. So the equation will be integrate 1 over 7 dx, upper limit 3, lower limit 1.5 plus integrate 1 over 7x plus 1 dx, upper limit 3.5 and lower limit 3. For the first integral, the integral of 1 equal to x. So we need to substitute the upper and lower limit into the first integral, which 1 over 7, 3 minus 1.5 equal to 0.2143. For the second integral, we are going to integrate x plus 1 equal to x squared over 2 plus x. Next, we are going to substitute the upper and lower limit into the equations. When we evaluate at x equal to 3.5 equal to 0.2143 and at x equal to 3 equal to 0.3036. So the answer for question B is 0.5179. For the first part of question C, first we are going to find mean equal to EX. So first we find the expected value. EX equal to integrate x fx dx. And then as usual, we need to substitute the upper limit and lower limit into the integrate. And then we need to add both parts of the integrate, which becomes 1 over 7 times 4.5 plus 1 over 7 times 15.8333. And then the mean value will become 2.9048. To find the value of variance, we need to find first the value of E times x squared. Using the formula of E times x squared equal to integrate x squared times 1 over 7 dx, upper limit 3, lower limit 0, plus integrate x squared times 1 over 7 times x plus 1 dx, upper limit 4 and lower limit 3. And then we are going to add the two parts of the integral, which will become 1 over 7 times 9 plus 1 over 7 times 56.0833 equals to 9.2976. And then once we have all the values to find the variance, we can use the formula given to find the variance. You will substitute all the values into the formula and we will get variance equal to 0.8597.
In conclusion, through this experiment, we learned how probability can be applied in real-life situations, like randomly picking sweets from a bag. We also observed that the result from our experiments, which are the experimental values, can be slightly different from the theoretical value due to randomness. However, the outcomes were still quite close to what was predicted. This shows that probability is useful and reliable in making predictions. That's all from us. Thank you.